The accepted wisdom that the science of acquiring seismic data had reached a peak and could not be improved has taken a battering, according to geophysical company PGS. The technology-focused oilfield service company says its new Geostreamer is a step change in seismic data acquisition. They say it's taken them 5 years to develop the technology, currently being used in a seismic survey of WA's vast northwest shelf. It'll allow petroleum explorers to peer deeper into the Earth's crust than ever before.
We have two types of sensor co-located at discrete positions along the streamer. We still have a hydrophone, but now we also have a particle velocity sensor. It's exactly like a dual sensor seafloor cable, but we're towing it through the water. And it's that process of towing it through the water that has historically caused all the problems. You have a lot of turbulence, if you like, transverse mechanical noise that propagates up and down the streamer. And the particle velocity sensor is particularly sensitive to towing noise. So previously, no one was able to engineer a streamer that was not swamped with noise at the low frequencies on the particle velocity sensors.
Andrew says this means two complementary types of information are gathered, which are processed together to produce a higher resolution product with different frequency properties. The idea, he says, is not new, but faced significant engineering challenges in development. The company built 4 different and independent generations of the device and tested more than 100 types of sensor to develop a new streamer designed to overcome the noise.
The depth of a seismic streamer with hydrophones is dictated by a notch that appears in the frequency spectra. And this is because you always have energy bouncing off the sea surface. So that notch in the frequency spectra dictates that the streamer depth historically is always between 5 and 8 meters. But now, because we have pressure and particle velocity sensors in processing, we no longer have a notch. So we can put the streamer much deeper, further away from the surface action of the ocean. Therefore, it's a much quieter environment, it's more stable, and it gives us some operational efficiencies.
Andrews says the improvements inherent in the new system could not have been made through enhancing the signal with software, despite the mathematical relationship that exists between pressure and particle velocity.
In principle, you can take an existing streamer and estimate or replicate the other seismic property, particle velocity, that we are measuring with the Geostreamer. But because you have a notch in the frequency spectra at regular intervals with your pressure sensor, you obviously do not estimate particle velocity wherever you have those notches. But with the Geostreamer, everywhere you have a notch in the frequency spectra for the hydrophone, you have a peak in the frequency spectra for the particle velocity sensor and vice versa. So it means they're complementary, and we are measuring real data, we're not trying to estimate it. And as I said, we're towing very deep, so we're using stable and quiet measurements.
Andrews says towing the streamer at a depth of around 15 metres allows for the collection of more precise data than has been available using a traditional streamer because it uses stable and quiet measurements.
Because we're towing deep, it works out that we're recording a much stronger low frequency signal. So we're able to see deeper targets with a clarity that was previously impossible. And because we now have a very rich frequency spectra, we boost the low frequencies and we boost the high frequencies. We have much higher resolution for all target depths.
The result, says Andrew, is a step change in technology and a seismic image many in the industry thought was unachievable. The interpreter, he says, gets higher resolution surveys that look deeper into the Earth's crust than with traditional 3D seismic techniques.
The basic process of exploration, identifying prospects, particularly ones that have subtle stratigraphic detail or that are very deep and are previously faintly visible, those types of marginal plays or prospects should now be far more interpretable.
Andrew says PGS hopes the technology will identify more new prospects and facilitate the description or delineation of others. Wayne Cant, Energy Spotlight.